All right, ladies and gentlemen, I want to welcome all of you to time series. Like I have said, it's based on your questions you will ask that you will understand. Don't wait to understand before you ask the question. Ask the question before you understand. So when you sense that you don't understand, you ask the question. All right. Time series. Forecasting. Can't believe I wrote a series as double. All right. So by the end of this study, you should be able to use forecasting methods that are useful for different work. Some of you will write long essay or dissertation. You will need this. You will need this. Some of you might want to predict gold prices, predict copper prices, predict palladium, platinum, several prices, even food prices. You want to predict the probability that you'll marry that boy or that girl. Forecasting. Time series, regression methods, they are all used for that. For this purpose, we are going to look at the component moving average, weighted moving average, exponential smoothing, adjusted exponential smoothing, linear trend, and if there is time, we will look at seasonal adjustment and forecast. If not, I'll record that as well and meet you. But it will depend on your understanding. Who can give me another word for forecasting? Just give me another word that comes into your head for forecasting. Precious.
Prediction, sir.
Prediction, you said?
Yes, please.
The prediction is what I have on my screen, so that one there. Let's go to Osei.
Fair projection.
Projection. Abubakar.
Look, the leader said what came to my mind.
Okay. Next person. Foster.
Estimation.
Estimation. Estimation is not really a prediction. It is a prelude. It's before the prediction. Joycelyn.
Dog anticipate.
Anticipate or anticipation. Okay. Moses. Moses, say something.
Doc, please, foreseeing.
What?
Foreseeing.
Foreseeing. Okay, Ella.
Doc, please to foretell.
Okay. So you have all the ideas of forecasting, conjecturing, surmise. All of these are examples of forecasting. Now, where do you apply forecasting? Well, many places. The meteorologists, they tend to forecast the weather. They will tell you that the weather is going to be 24 to 28 degrees Celsius from the northwest monsoon winds across the equator and the meridian. They speak a beautiful language. They are forecasting. Strangely enough, most of the forecasts, people tend to have doubt about it. But that is one area you can apply forecasting. Can you think about another area where you can apply forecasting? Frederick.
Doc, please, casting of Lotto, this Lotto casting. You assume two numbers, too sure, and then you go and.
But that one, is it calculated? We are talking about where you have something proper calculated. There is a system you are following.
Doc, they have a book, a graphic they use to do their calculation.
The way you are justifying it looks like you've been enjoying it. Echo. Echo, what do you have?
Stock market.
Stock market. Very good. Alfred. Emmanuel.
Dog, earthquake.
Earthquake. Okay. Alfreda. Priscilla.
Sir, please, sometimes inflation.
Inflation. Priscilla, please lower your hand.
Investment return forecasting.
All right. So at least all of you have some ideas about it. Sportscaster predict the winners of a football game. That's forecasting. Managers will forecast the future demand of their product. Even people are forecasting COVID-19. Okay. If it is poor forecasting, problem. Poor inventory will come in, staffing decisions will come in, shortage, inadequate customer service, and so many complaints because of that. So we need a technique. That's the point. We need a technique. And what is a technique? Managers use techniques. One of them is judgment. They'll tell you that based on my experience, I don't buy that, but hey, some of them tend to work. Expert opinion. There's a Delphi method that people use to forecast future using informed judgment. Okay, this is well collated judgment. Sometimes you even collate the information and weight them, attach importance to each information, and then you can judge. Past experience, technological forecasting, all of these things managers tend to use. Okay. But the key one we are going to use is the mathematical and analytical method of forecasting. We are going to basically look at two of them, time series and regression. You will also do regression under my tutelage next semester. I'm sorry, you can't run away from me. You're going to be needing me all the time. So start befriending me, okay? All right. So I will beg of you to have a book and a pen with you. That way you can fully understand this topic once and for all time. Okay. So let's look at the components of forecasting. What makes a forecasting, analytical forecasting good? You need to know the component. A component are the parts of something. One of the things you need to know about forecasting is time frame and patterns. You need to know the time frame and then the pattern. Because forecasting requires time. Because things don't happen at the time you forecast them. Now, the time frame, there are basically three of them. Short range. Be taking notes, be writing as much as you can. This is the only way you can master this. There's a reason why I've not given you the slides earlier. I want you to take notes here. So you have the short run, which is usually 1 to 2 month forecast, medium, long. The long one is more than 2 years. So the time frame matter, and you're going to see. The pattern. Now, there are 4 major patterns, sometimes 3, but there are 4 major. You have the trend. You got to pay attention here, because the thing is beginning to get exciting. You got to distinguish between a trend, a seasonal pattern, a cycle, and random variation. Okay, write them down. A trend, a seasonal pattern, cycles, and then random variation. I'm about to show you a picture. Okay. And please, the picture I'm about to show you is not following the order in which you see them. So yours is to tell me, based on your calculated guess, which one is which one. That's why I'm saying you should write these ones down, first of all. What is the difference between a trend and a seasonal pattern? What is the difference between a trend and cycles? What is the difference between seasonal pattern and random variations? Have you written them? Have you written them?
So please come again.
I'm sure most of you have written them, right? If you have written them, say yeah.
Yeah.
Very good.
Yeah.
Now, we are going to look at some of them. You tell me which one is a trend, pattern, cycles, random variation. Let's start. You have A, B, C, D. Which one is A? Which one is A? Be careful. Be careful about everything you see on the screen. Remember that we are matching demand on the y-axis against time. So as time goes from 0 to the right, demand is either rising or falling or something. So the first one, is it a seasonal pattern? Is it a cycle? Is it a trend? Is it a random? What is it? That's A. There's a clue there for you, actually. Okay, I know. Okay, so I'm going to define some of them for you, then you can appreciate it. Now, so that you can compare it here. When we say a cycle, we are talking about up and down movement, or repetitive movement. Up and down, repetitive movement. The movement is repetitive. The movement is repetitive. It is a repetitive here means that it is the up and down are the same, more or less. It's not like one big up, one big down, one small up, one small down, one big up, one small down. No. It's the same kind of up and down, up and down, up and down, up and that's a cycle. Please, do you get me? Do you get me?
Yes, so.
Yes, sir.
Okay, so that is the definition of up and down. Let's go to the next one. The next, and I'm coming to the picture, but I'm explaining them to you. The next one is a trend. In fact, it doesn't follow any of the pictures, so I'm just mixing them. A trend is a gradual, long-term up and down movement. Gradual, long-term up and down movement. So the difference between that one and a cycle is that the cycle, the up and downs are the same, up and down, up and down, up and down, up and down. The gaps are not too different from each other. But then the trend, it can be pop, 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 then boom, pop, then boom, down, pop, pop, then boom, pop, then boom, pop, then boom, down. So that is a trend. Now, the seasonal pattern, as the name sounds, it comes when there is a season. So normally it's down one, then boom, one up. Or it's flatter, then boom, up. It's flatter, then boom, down. That is seasonal pattern. It's up and down movement, repetitive movement, but within a trend, occurring periodically. And then final one is the trend with seasonal pattern. The trend with seasonal pattern. So remember, first of all, note that when we say something is trending, it's either rising or is falling generally. It's either rising or is falling generally. It's not, and in the process of the rising or falling, there will be up and downs. So on the basis of this, you can tell me which one is the A. Which one is the A? Joel.
A is a trend.
A is a trend. There's no question about that. A is a trend because there is a gradual movement and you can see that it's going up. And there are ups to the up and down, but then there's one boom down, one boom up. But then the majority is up and down, up and down, up and down. What about the B? The B.
B is cycle.
Someone is talking and disturbing us. Grace Jamie. Grace Jamie, check your microphone, okay? Patience Afro, check your microphone and mute yourself. All right, let's go to Echo. Bruce.
B is cycles.
B is cycles. There's no question about that. If these were exams, you would have gotten it. Let's go to the third one. The third one, which one is that? The C. That one is obvious because of the way I explained it. Elsie.
No, please, it's seasonal patterns.
It is a seasonal pattern. And then the last one, as for that one, the last one, patience,
There is a circle.
is what a circle.
Seasonal circle. Seasonal pattern.
But that's what somebody just said. Somebody just said about that one. So that's not right. Foster.
No, it's a trend.
It's a trend. Okay. Now there's a mix. Asai?
No, please, it's the trend with seasonal pattern.
That's the answer. That's the right answer. It is a trend, but it has seasonal pattern. Because the trend up there, the other trend up there is not the same as this one. This one, the jumps are really, really seasonal pattern, just like the sea. But just that it has an upward sloping situation. So it's a trend with a seasonal pattern. If this was an exam, most of you will get it correct. Most of you will get it correct. So that is what we mean by the forecasting component. Up here.
Doc, please, can you go over what a seasonal pattern is?
A seasonal pattern is where, it is flat. Normally it's flat. Then there's a boom up one or boom down one. So things are normal, like Christmas. Christmas, when you look at the year, okay, the year, you have January is a bit quiet, maybe a jump at the beginning, demand goes up. Then it's flatter till Valentine, then boom, one. Then it's flatter till April, there, boom, Easter. After that, it's flatter till December, boom. So that is what we mean by seasonality or seasonal pattern.
Thank you, Doc.
All right. So those are the information that you have here. You see, when you learn as though you have no notes, you take more notes and it helps you to understand better. So when you're learning, please learn as though you have no notes. Okay. Now, let's delve into time series. Now that we know the pattern, what are the methods you can use to forecast? Time series is one of the methods. It's a statistical technique that uses the past information or data to forecast or to predict the future behavior of something. It assumes that what occurred in the past will occur in the future. Basically, human beings behave the same way. The same things that have happened to the Israelites is similar thing that is happening to us. The only difference is that they didn't have WhatsApp. But there is a certain way of behavior that repeats itself in time. Forecasting is done here only based on time. Write it down. Time series forecasting, as the name sounds, requires time. Whether the time is in seconds, minutes, hours, days, weeks, months, years, decades, it doesn't matter. It doesn't matter. It doesn't matter. What matters is that there is time. Time. Okay, so that is time series forecasting. Another method we'll be using is known as regression. And like this is the mother of, most of you have done this undergraduate. Regression looks at the association plus the causality. It doesn't look at, things are correlated with each other. No, it looks at beyond the correlation, what is driving the correlation. There could be a correlation between, for example, right now in the shops, there is possibly a lot of people demanding or buying goods at Makola. And when people are buying goods at Makola during Christmas, people think that, then people will not buy goods at the restaurant. They will not buy food at the restaurant. But you go to the restaurant too, they are also selling a lot of food. But you can't say that because people are buying food, because demand is high at Makola market, That is why demand is high at restaurants. No. They are associated. The correlation between them can be 90%. They are associated. But it doesn't mean that one is causing the other. Okay. Other factors behind them is causing them to behave the way. Regression will normally have some factors inside it. We'll look at them. A typical example of a regression is when you're looking at the relationship between price and quantity demanded. Who remembers the economic definition of the law of demand? Who can tell us? What does the law say? The higher the price, the lower the quantity demanded. Remember, I told you that your energy is what gives me back the energy. And I've also told you that this topic is a topic where you will get you can score a lot, most of your marks, even than the queuing model. So take note. All right. Another example of a regression is when you look at the relationship between blood pressure and the weight of a person. In fact, you can look at several other things as well. And then finally, there is a qualitative method, the one we spoke about earlier. So all of these are methods you use. Let's start with the first one, the time series. And we are looking at moving average. Write it down, moving average. Moving average uses not just the past, it uses the recent past. It uses the recent past to make the forecast. Recent past. It will dampen or smoothing out, and I'll explain that pretty soon. It will dampen or smoothing out random increases and decreases. Things can happen abnormally. All of a sudden, bang, there has been an increase in demand. You cannot use that increase in demand of your product to say that, oh, life is going to be good. It's just random. It just happened. All of a sudden, things have gone out that way. Or there has been a downturn in your demand. It doesn't mean that life is going to be hard like that. Okay. Now, what the moving average will do is to level the playing field so that you are not influenced by the jumps and the falls. You are not influenced by them. It's very, very useful when, we are forecasting stable items that don't display a trend or it doesn't display a seasonal pattern. As you can see, Christmas display a trend of seasonal pattern, so we don't look at it. This one is not like that. Okay. Now, this is a formula for the moving average. The N you see is simply the number of moving average you are dealing with. The number of periods. The number of periods. So if it is months, it's going to be the number of months you are dealing with at that point in time. If it is weeks, it's going to be the number of the weeks. So if you are looking at 4 different weeks or 11 different weeks, that N becomes that. The D is simply the demand. Okay, the demand, the data point. Okay. That particular number, that particular demand at that period I. Okay, just a second. Okay, so please write this formula, okay? Write this down. You don't want to write all the manya things. And also remember that some of these will be given to you. But the key point is knowing that you are just looking at something that says that, if the A, B, C, D are the demand, okay? If A, B, C, D are the demand, this is going to be the moving average. And if we are looking at 3-period moving average, okay, 3-period moving average, I will just divide it by 3. And the items here might be 12, or it might be 12 different months. and I'm looking at 3-period moving average. But if I am looking at 4-period moving average or 5-period moving average, it will be A plus B plus C plus D plus E divided by what? Divided by what?
Five.
Okay. So you got to follow me, guys. You got to follow me because I'm asking questions so that I know you are there. The moment I feel lost, you see me just flying. That's why you get confused along the line. If you're not paying attention because you didn't think that you're going to be writing, I will implore you to stop everything. You see, I'm begging you because I know how this is going to be important for you after your holidays. I know. And then you will start worrying. Okay. Now, let's take an example to hone on this point. So here you have some 10-month data on product orders. It's from a company known as Instant Paperclip Supply Company. Okay. Now, we are going to find the forecast for November. As you can see, we don't have the value for November. We have the value for, or the demand for each month, not for November. We have the orders for each month, not for November. In the month of January, there was 120 orders. February, there were 90 orders. March, there were 100 orders, and on and on. How many orders do you think are coming in November? How many orders? There's a forecast called naive forecast. I didn't even tweet it. The naive forecast will just take the last period, and then we use it to forecast November. So the naive forecast will say that November value is going to be what? Who can raise a hand and tell me? The naive forecast will say that November orders is going to be what? Sadat. Yes, Ebenezer.
Doc, 70.
70. That is wrong.
Yeah.
Let's go to another person. Hello.
90.
90. Okay. So the naive forecast would have said that let's use 90 to forecast for November because he uses there. It's very naive. He just looks at what is there and then it forecasts. But that's not what we are going to. We're going to use moving average. Okay. Moving average. So we are going to find the 3-month moving average. That's what we're going to find for November. Find the 3-month moving average. When you've done, raise your hand and tell me. Find the 3-month moving average for November. Raise your hand and then you tell me. Ebenezer. Eric Edu.
110.
110 is the right answer. Okay. Eric, show them how you did it.
Okay, so I picked the most recent 3-month data, which is August, September, and October.
I know how you
So
took it, but I always want you to take it from the earliest, from the closest to the November, in that order.
Okay. All right. So I took the orders in October, September, and August, and added them, which gave me 330 divided by 3, which gave me the 110.
That's it. Guys, that's it. If this was an exam, it's easy. Okay, find the next one. Find the 5-month moving average. Find the 5-month moving average for November. What do you mean? Many be. Catch us say, oh, why busy? Many be. Robert.
W is 47.
47 is wrong. Grace.
91.
91 is correct. Remember, it's a 5-month moving average. So you take from the bottom the last 5 before November, sum them, divide by 5. Okay. And when you do that, you're going to get 91 orders. So basically, what moving average is doing is just picking these things. Now, I gave you an Excel sheet. And in that Excel sheet, we can calculate the moving averages. Okay. So, I mean, you can just pick it and then we do that together. So this was the data that you have. I've calculated them here, but I want to delete them quickly so that I show you how I did them. So I'm going to delete the answers quickly and then I'll show you. Remember, if I tell you that, give me the 5-month moving average. You're supposed to give me 5 months and not 3 months or 4 months. So if you have your Excel opened, these are the orders. What you got to do is go to the data tab at the top. On the far right, click on data analysis. If you don't see data analysis, you know how to do it, like we used to do for solver. So click on data analysis here. And then a pop-up will come. In the list, scroll to M and look for moving average. Scroll to M for mango and look for moving average. And then in the first section, delete everything that is there. It says input range. Highlight everything, including the heading, orders, not the month, just the orders. Okay. And then you will have the November as well as part of it. And then in the interval, oh, by the way, after that, take labels. Take labels in first row. And then under the interval, that is your 3 months. So if it is 3 month moving average, write 3. Let's do the 3 first. And if it is a 5 month moving average, you will later come and do another one for the 5. Under your output range, you should select output range and pick on, stop the first one. Leave the first one. Because the first one, first of all, doesn't have any past. So leave the first one and click on the second cell where you want your results to be. Okay. And then come down and check chart output. Take it. Take the chart output and click on it. Okay. Yeah, I made a slight mistake. Ideally, you're not supposed to include the last. I think when I was picking, I included the last one. Okay. You're not supposed to do that. So let's delete it and just follow me. Delete. And just click on the data analysis again. Choose moving average again. And instead of selecting all the data, including the empty November, don't include the empty November. Do it up to October. Okay. Everything else will remain the same. And click enter. And that's it. So what you get here is an interesting result. This is a 3 month moving average, and you see that is a graph. The actual forecast is the data you have here, 120. They are the ones in the blue. And then you can see that it jumps the first 2 periods and started with the 3rd period. Okay. Started with the 4th period, actually. And you can see they are the ones in red. So the forecast is that. So the idea is that you want to see the difference between the forecast and the actual. The difference between the forecast and the actual is called the error. It's called the error. And normally we calculate different kinds of average errors to see whether the forecast is good. But the key point is that you've been able to forecast November. November is 110, as you can see. Joycelyn.
Oh, please, you said the difference between the actual and the forecast is called the error.
Yes, the error.
Okay.
Yeah. And there are different errors you calculate. You can calculate the mean absolute error, the mean squared error, the root mean squared error, the mean absolute percentage error. All of these errors you can calculate, and I see the one with the lowest error. The one with the lowest error is the one that you're going to choose as your guide. But here, our forecast is here for November. It is beautifully seated there now. Okay, this is moving average equals to 3, where the period is 3. When you want to do for moving average where the period is 5, it's the same thing. Change this 3 to 5. Go to the data tab again. Just click on the data analysis. Enter. Just change the interval from 3 to 5 and drop down. Oh, I made a mistake. Where you want the results to be, go and click the second row and click enter. Okay. This 3, 5, 5-month moving average, that one is here. Okay. That one is this one here. And you can see clearly from here that the forecast for November is 91. That's it there. It's 91. Okay. So if you use the 3-month moving average, the forecast for November is 110. If you use the 5-month moving average, the forecast is what? 91. That should tell you which one is giving you a lot of forecast. So normally as you are increasing the moving averages, what do you see about the forecast? What do you see about the forecast when your moving averages are increasing? When the period of averaging is increasing, what happens to the forecast? Jemima. Abugiri.
It decreases. The forecast decreases.
Exactly. So once you are given a picture like this in an exam, okay, and you are told which pictures are these, what do they show? You can just look at the picture where it starts, and you say, oh, this one is starting at 5. So it's a 5-month moving average. This is starting at this, and then you can calculate the moving average, just as we manually did some of them. Okie dokie. So now we can proceed with our next method. The next method of analysis is known as so everything we did is here, so you can check it. And then the graphing is here, so you can check it as well. Let's go to another method known as oh, by the way, some conclusions here. We've already said them. That when the longer periods are moving average, they react more slowly. As you can see, the values are smaller than the shorter period moving average. So you can see that the 3-period moving average is faster than the what do you call it? The 5-period moving average. The other point is that the appropriate number of periods to use is try and error. So which one should I use? Is it 3? Is it 4? Is it 1? It's try and error. And by the time you use about 4 of them, you've gotten a trend. Moving average does not react well to changes in trend. So if there's a trend, moving average will suffer. If there's a seasonality in that period, moving average will suffer. They will not capture that. But the best thing is that it's the cheapest way to start, okay, as you can see. Very good for short-term forecasting, like that. Okay, let's go to the next one, which is the weighted moving average. The emphasis is on the weighted. In fact, let me just show you the formula. You see that it's similar to this, just a small difference. Weighted moving average. What is that? Well, as you can see, you have to weight. Weight here means you have to set importance to the demand. So that one, you are not finding the average. You are rather attaching some weight to the others. And then you sum them up. Finish. Weight and sum them up. Add some weight and sum them up. So suppose you are told that, and the weight is always 100%, the total number of weight. So if I tell you that you should do 3-month weighted moving average, and I give you the weight for 2 of them, you should know the weight for the last one. Okay. So let's take an example. Like I said, the weight add up to 1. That's what you see there. Let's go to the paperclip example. Suppose that The company weighs 50% for October, 33% for September, and the rest for August. Okay. What would be the weighted moving average? You remember the data? Okay. This is the data. This is the data on the first and second column. What would be the weighted moving average if you have 50 for October, 33 for September, and then the rest for August? What would be the weighted, the 3-month weighted moving average? So it will be 0.5 times what?
It's 90.
0.5 times what?
90
Okay. Plus what?
plus points 333 times 110
Plus what?
plus
17.
It's like some of you are talking, don't want to talk. Okay, so this gives you the final answer. When you do it, you're going to get 103.4. That's a weighted moving average. Okay, let's go to the fourth one. The weighted moving average is easy.
Doc, please, how did you calculate it?
Calculate what?
The weighted moving average.
Calculated it.
The 103.
Copy the last thing on the red, the bottom. That is how I calculated it.
Okay, Doc.
The one who is writing on my screen, you're not asking me questions. You're not asking whether you can write on my screen and you're writing. Okay. Now, let's go to exponential smoothing. This is where the questions normally will start from. Moving average and weighted moving average are easy. Exponential smoothing is an averaging method. There's no question about that. It's still an averaging method. It weights the recent past more strongly than distant past. It gives more importance to recent data. They are all past, but the one that is closer to recent, it puts more importance on that than the one that is far away. They are all past though. Now, why is it called smoothing? Because the importance are computed automatically. The importance are computed automatically, and they become smaller and smaller as the observations move further into the past. So in other words, if you are closer, let's look at our November example. Those orders that are closer to November will be given more weight, more percentage, more importance, like October, like September, like August. They will be given more weight than those that are far away from November. But how is it done anyway? Well, there are two forms, and we're going to look at the two forms. The first one is easy. The second one is hard. The first one is known as a simple exponential smoothing. You will get a question on that. The second one, you'll get even more question on that. Let's look at a simple exponential smoothing. Please write it down that the opposite of the smoothing is the dampening. The smoothing is a parameter. The dampening is the opposite. The two together will give you 1. The two together, you remember, it's a weight. Weights are always in percentages. So write this formula. This is a formula for simple exponential smoothing. This is a formula. You will be given the formula, but you should know what it is. What is a FT? It's a forecast for the current period. It's a forecast for the current period. What is a DT? It's a demand today. It's a demand for the current period. What is the alpha? The alpha is a smoothing parameter. The alpha is the weight attached to the current demand. And of course, 1 minus alpha is the other weight attached to the current forecast. So note the difference between the current demand and the current forecast. So the FT plus 1 is actually the forecast for tomorrow. Okay, the forecast for the next period. The D is the actual demand. The FT is the previously determined forecast for the present. And like I said, the alpha is the weighting factor or the smoothing constant. It is an importance attached to the current demand. And I also did say that the opposite of the alpha is what? What is the opposite of the alpha?
Damping.
The dampening factor. So if the alpha is 0.2, what is the dampening factor?
0.8.
0.8. Okay. Now, pay attention to this first point before we start. The forecast for the current period, if you look at the formula, this is a forecast for the next period, and this is a forecast for the current period. If I want to know the forecast for the current period, I don't have the past. You see, this one is depending on the forecast for today, because this is the forecast for tomorrow. Okay, the FT plus 1 is a forecast for tomorrow. The FT is a forecast for today. So if I want to find the formula for the forecast for today, FT is actually going to be the alpha for the demand for the past, T minus 1, plus this one, 1 minus alpha multiplying the forecast for the past. But when you look at the data, we don't have forecast for the past. We don't have forecast for yesterday. So if we don't have forecast for yesterday, then this one will go. And if that one goes, then you don't need the smoothing parameter, because the thing is that the smoothing parameter is not used only on demand. It is used on both demand and or you can say that all the smoothing parameter is given to the demand. And if it's all is given to the demand, then it means alpha is 1 and 1 times D. So that is why the FT becomes equals to the DT. That's why I put here that anytime you are doing forecast for the current period, is the same as the demand for that period. It's the same. It's the same. Keep that in mind. And I'm sure all of you have written the formula away. Okay. So alpha, what are some of the values of alpha? 0.1 is one of the common values of alpha. 0.3. But most of the time, it's going to be between 0.1 and 0.3. That is usually the alpha. Okay. Let's take an example, real life situation. The PM computers assemble customized personal computers from generic parts. It assembles computers mostly at night from a variety of sources whenever they choose or they see a good deal. They want to develop a good forecast of demand for their computers to know how many computers or component parts to buy and stock. It has accumulated the demand data for its computers. The past 12 months, it has collected the data and they've given it to you. And from that data, you are supposed to compute the exponential smoothing forecast for February and March, and then all the months. Use the smoothing constant of alpha, which is 30%. When you're done, you do for alpha, which is 50%. Ladies and gentlemen, this is a problem of the day. How do you go about it? This is manual calculation first of all. So this is the data set. Look at the data set. For the period 1, January, demand was 37. For period 2, February, demand was 40. But for period 13, January, demand is not known. And your job is to forecast demand for that January, demand for the February, and then on and on. But actually, you're supposed to forecast demand for the 1st January. But January, we know the demand, right? There's no demand. Okay. There's no forecast for January. But we can get the forecast for February. That's what the question says, forecast for February and March. So when you go, you are going to find the forecast using that formula, the forecast for this. So, first of all, what to be the forecast for January? F1. That's a question. Remember what we said before? F1 will not be there. F1 will not be there. F1 will be for the other one. But technically, F1, the forecast for period 1, is not going to be there. The current forecast is not going to be there because it requires you to have the previous. I don't have. Okay. So let's see how you start the whole thing for the February that they're asking you to find. When I say forecast for February, I was talking about January, but the January can't. So if I were to create a column for January, January will be dash. Let's look at how the real ones continue. You are told to use a smoothing forecast constant of 0.3. And then when you are done, do for 0.5. This means that this is the smoothing parameter or forecast. What will be the dampening one? What will be the dampening? The dampening will be what?
So 0.7 for the first one and 0.5 for the second one. Very good.
So someone is asking, why did I exclude January? Okay. It's like, we kind of want until we disappear. Okay. Why exclude January? Who can help the guy? Constant.
The demand that comes after January, that comes before January. That is why we are excluding.
Sorry, I can't hear.
Okay. Because I said that we don't have the demand that comes before January. We don't have that. So we're excluding January.
Okay. So, that's a perfect answer. So, guy, if you are looking for forecast for January, you will need alpha times demand for, what do you call it? You need demand for before January, which I was going to call, but I'll call it not 1, but 0 minus 1, plus the 1 minus alpha, and then you need forecast for before January, which is 0 minus 1. We don't have any of these information. We don't have forecast for this. We don't have demand for January. The month before January, because we are looking at January. And then we don't have forecast for the month before January. So everything else will be 0. That's why I say dash. Hope you get it. Now, let's go to F2. For F2, you need alpha, and then you need D1, demand for January, plus 1 minus alpha. You need the forecast also for January, because you are predicting February. The 2 here means February. So what will be the value of that? Simple exponential smoothing. Who can raise a hand and tell us? First of all, the value here for the alpha is what? 0.3. And then 1 minus alpha is 0.7. You have a plus in between. The D1 for alpha is what? The demand for that January is what? It's 37. That's it. Okay. So that is 37. What about the forecast? The forecast for January. Sorry?
There's no forecast for January.
Yeah, but we were told to do something earlier on.
37.
Sorry?
37.
Okay, good. Why?
Well, you stated that the forecast for the current period is the same as the demand for the current period. And the current period is January.
Exactly. Okay. So the current period is January, which is the 1, and the forecast for that is the demand for that. So for this case, we will take the same value we are using for the demand for January to represent that of this. So that is going to give you the forecast for February, or for the next period, which is February. What will be the value? Take your calculator and find that. Yebi, oh, yeah. Yebi. Don't make us talk a lot. You do some. Just do some. Yes, Richard.
37.
Exactly. So when you do that, you're going to get the forecast for February to 37. So if I was making notes here as forecast, this February is going to give me 37. Very good. Now let's look at forecast for March. Forecast for March will require that you have your D2, 1 plus 1 minus alpha F2. So what are you going to get for the forecast for March? What do you get? Richard?
Sir, 41.
41. So explain how you got it. You did 0.3?
Yes, please. 0.3 times 41.
Is it 41?
We are forecasting for March, right?
It should be 40.
To be 40
No,
and
40.
not 41.
Okay, times 40. Okay, so the answer is 40 then. 0.3 times
So you
40.
made a mistake in your answer.
The answer is 37.9.
Yes, 37.9.
So you see, people are working on. People are working.
37.9.
Yes, you're supposed to get 37 from them. Okay. So you get minus plus 0.7. They use the forecast that we had. And then when you now manipulate this, you get 37.9. Let me show you the result. You should know what you're doing now because this is guaranteed exam question.
Okay.
Okay. So this was the first one. And then for March, which is we just did, is going to be 37.9. Yes, you ma'am.
So please, for the alpha, we have two values. Can you please explain
We
what
are
the second
using
one?
0.3 throughout.
Oh, okay. Okay, thank
We are
you.
using 0.3 at the end. And then after that, we now do 4.5. That was what the question was.
Oh, okay. Thank you so much.
Okay. So I don't want to go to April because you should be able to now calculate for April. Right? Who can tell me the value for April? You have to calculate. Yes, I said.
Doc, it's 38.2.
38.2. Very good.
That's 8.83.
Yeah, it's supposed to be 8.3. As I say, some will
30.
always make mistake.
38.83.
Some will always make mistake if they rush. If this is an
Doc,
exam, it means that you have a challenge.
Doc,
It's a,
it's 40.
it's a substitution that may have worried you. So for F3, F4, you will need the 0.3 times the current demand for March, which is 41. Okay. Plus 0.7 times March forecast. And what was the forecast for March? We already have it as 37.9. At this stage, the job is done. Just take your calculator and get the answer. You should get 38.83. Do you understand?
Yes, sir.
Yes, sir.
Anytime you are writing this, then have the formula in front of your eyes. Don't be using your mind to write the substitution. The formula here must be in front of your eyes whilst you are writing. Okay. And always remember that these ones are the past values. First is the past demand. The second is the past forecast. Okay. So we've been able to do for alpha, which is 0.3. I'm sure you can do for alpha, which is 0.5. So we're not going to go there. You should be able to do that. We are now in a position to find the forecast for all of them. So you can see that when alpha is 0.3, these are all the forecasts. And when alpha is 0.5, these are all the forecasts. Match that against your own that you did. And if you keep going like that, you'll be able to forecast for January next year. Okay. So now, simple exponential smoothing, done. Let's go to the next one. The next one is known as, okay, let's look at some few things about the simple exponential smoothing. The forecast that uses the higher smoothing constant react more strongly. So look at it, what I did for the 0.5. So if you look at 0.5, 0.5 smoothing parameter, the values are generally bigger than the 0.3. That's the point we are saying. They react more strongly to changes in demand than the 0.3. Okay. Both forecasts lag behind the actual. Look at the actual. When you take the actual here, okay, you see that both of them are behind the actual. When you get here, both of them are behind the actual. That's the point we are discussing. Next, both forecasts tend to be consistently lower than the actual. I think I would say that. And finally, low smoothing constant are appropriate for stable data without trend. So when you have higher smoothing constant, they are appropriate for this. Now let's go back to our data set, the one I gave you. And there's an Excel way of calculating these things easily as well. And whilst I'm doing this, I just wanted to also be able to know that these things have got Excel. So click on the PM. Yes, Tama.
Please, I wanted to find out, would there be any situation where you are asked to calculate the forecast error using like the figures you've come by after the forecasting for both alphas?
Yeah. So when we're done, we'll calculate the forecast error. Some of them. The forecast error, there are different methods of calculating them. So it depends on which error you want to calculate. Whether it is a mean absolute, error, or you're going to calculate the mean mean absolute percentage error or something else. Or you're going to calculate MSE, mean squared error. Yes, Isaac.
So in the previous data, the forecasting data for July, for example, was higher than the actual demand figure. Is there explanation? Is there any explanation? Because as mentioned, normally they should be lower the actual ones.
Yeah, generally speaking, not specifically.
Okay.
Generally speaking.
Is there any reason for that when it becomes higher than that?
Is there any reason why the demand
Is there any explanation? Yeah.
Why the demand is higher?
Yes, sir.
But the demand you're using, that is current information you have. If I tell you that I have current information, and you tell me that, okay, you have past information, which one should we rely on most of the time? When you are doing research and you are downloading papers from 2000, and I'm downloading papers from 2020 coming, which one of them is more reliable?
The current, sir.
Yes. So that is why demand is consistently larger. Yeah. Because the information is rich. That's the whole point. It's new. If it's new, you get better outcome. All right. So click on the data tab. If you look at the one I've sent you, I did the alpha equals 2.3. So click on the data tab, choose data analysis, and this time select exponential smoothing. You see it in the list. Exponential smoothing, and double click to open. Now, if you check carefully in the exponential smoothing, I have actually in the input range, I've selected all of the column together with the January one, we don't know, the empty one. So take note, we don't know the empty one for January. So January 1, 2 has been added. Okay, so you put that into the input range. Okay, and then the dampening factor, you see here, the Excel is using the dampening factor. So it means that you cannot use your 0.3, which is a smoothing factor. You have to use the dampening factor, which is a 1 minus a 0.3. And that is why you can see that I've written 0.7 there. So you put that same 0.7 there. Okay. Oh, but in this case, we are using alpha of what? 0.5. So you have to change the dampening factor. Okay, to 0.5. Because the opposite of the smoothing factor of 0.5 is the dampening factor of 0.5. Then you check the labels and then the output range. This is where it's interesting. Where you want the output to be, go and select the first cell, which is January. Just click on that. And enter. It will also show the chart. There you go. So you are able to see that the actual forecast, looking at the graph, okay, the actual forecast is the blue one, is above that of the forecast. The actual data is above that of the forecast data. And you can see clearly the trend that he spoke about in our language. If you want to calculate the errors or forecast errors, you can calculate the forecast errors by looking at the gap. I'll show you. I mean, I have all of these things done. Okay. We've been able to just generate this. We did it manually. We've done it online. Excellent. So now let's go back to the slides and continue the journey. So these are all the results that you can see in the slides. Okay. Let's go to the adjusted exponential smoothing. That one is not a joke, but you crack it. Adjusted exponential smoothing. There's a formula for that. Okay, forget about the error. Adjusted exponential smoothing is an exponential smoothing forecast with a time trend. This is key. Write it. It has a trend adjustment factor. Okay. Normally, the forecasting is ft plus 1 equals to alpha dt plus 1 minus alpha, then ft. Okay. So this whole thing is this ft plus 1. But this one doesn't have a time trend. That one has a time trend. So you add a time trend to this before you can now have a adjusted, as the name sounds, adjusted. So the adjusted, okay, ft plus 1, this adjusted is this whole thing, which is the ft plus 1 plus a time trend plus a time trend. What is that? What is that time trend? What does that time trend really mean? Okay, let me show you the formula so that you can appreciate it even more. So this is it. Remember that all of them are t plus 1, t plus 1, t plus 1. So you are all looking at tomorrow. You're all looking at the first one is adjusted forecast. Should depend on the forecast plus the time trend. Okay. What is a t plus 1? Well, first of all, you should know that t is the smoothing trend factor. That is a t, the smoothing trend factor. As for the t plus 1, we already know it. That is this one. What about the t plus 1? That is a key one. The t plus 1 is the time trend. And that time trend, watch it carefully. A part of it, we call it beta. A part of it depends on the forecast, the two forecasts. The one in the current period, okay, and then the one in the future period, which is a t plus 1. It has a factor it depends on. And then 1 minus that factor is the trend one. The factor here are talking about the importance that you are attaching to the thing. The importance, yeah. Set up. So this will give you that value. Now, the T is the last period. In fact, I made a mistake. The first T here is not a T, it's a beta. The beta is a smoothing trend factor. The T is the last period. The T underscore T is the last period trend factor. Okay. And then the beta is a smoothing constant for the trend. What is the beta? Once again, the beta is between 0 and 1. What is the beta? It tells you the importance given to the most recent trend data. That is a T plus 1. Okay. Plus the 1, which is the forecast. The importance attached to each. So write this formula down. Okay. See, you see the formula up here. This formula here. I can write it as A F T plus 1 equals to, then instead of this one, I write this. Alpha dt plus 1 minus alpha ft. Then I add this time trend plus beta into brackets ft plus 1 minus ft plus 1 minus beta t. Very good. So this is the adjusted forecast, where the first part here is just the forecast from the previous one with the first part is simply the simple exponential smoothing. And then the second part here is a time trend. That is the adjusted exponential forecast. So let's go back. Now, for us to be able to do this, we need to know the value. We should be giving the value of alpha and the value of beta. That's it. Before we can ever calculate adjusted. So let's go and see. If the beta is big, it will tell you that trend changes more than before. Okay, so let's go back to the one that we did. Please, this time, look at the top. I know the previous one we were using the alpha for the 0.3, if you can remember. But this time we are going to use alpha of what? 0.5, and then a new beta of 0.3. Alpha of 0.5 gave us the following forecast, don't forget. Of course, we didn't do that one because we're doing the 0.3. But for this one, we are using the 0.5. Are you following? Okay. So, two important things I want you to note down. This is the difficult part, so pay attention and get it. First one is that we need to know F1. We need to know the value of F1. What do you think is going to be the value of F1? The forecast for January. What do you think is going to be the forecast for January? If you remember the formula here, I mean, you can see it for this one, you can see it. If you remember the formula, okay, ft plus 1. What is going to be that? To do that, you need to know the demand from the previous. Okay. Be careful, because I know that there will be some ideas that will come into your head and you might think that you are right and all of that. But just, what is the forecast? It's tricky, but it's there. It's tricky, but it's there. What is the value of the forecast? Somebody says 0. It's not 0. Now that we are going to actually calculate. So look at this one here. Oh, look at this. Alpha is 0.3. 1 minus alpha, sorry, alpha is 0.5. Don't forget. Alpha here is 0.5. Demand from December We don't know. So that is not there. But there is a rule I'm going to give you when you're calculating adjusted exponential forecast. First of all, this one is not there at all, so the whole of this is 0. But we can say that F1 is the same as F2 and is the same as D1. What is D1? Let me put it here. Hey, are you guys watching my screen?
Look.
Okay, so watch this. So F1 should be F2, and that should be D1. And that is what?
$37.
That is 37.
Sorry.
So for this purpose, F1, F2, all of them are 37. We're talking about forecasting. Now, ideally, we know for F2. We know for the F2 to be 37. We are using that F2 for the F1. Okay, so remember the formula. Go back to the formula. The formula requires you to know the value of what? Days. Oh, come on. You need to know the value of days, and you also need to know the value of that. We know this one is 37 for F1, 37 for F2. Okay, I know that. What about this? T1. You see, T1 itself is T underscore T plus 1, technically speaking. What is that going to be? Let's go back here to the formula. Okay. What would that be? T1 or T is going to be 0. Even if you look at the formula, it's tell you. Okay. Let me just go back to the formula. Okay. Look at the formula down here. Even if you know the value of beta, and beta is 0.5. Okay. And here, we said that this one is what? Is 37, and this one is 37. So that makes the whole thing 0 there. Okay. And we don't know the past value for the T. And therefore, the whole of this is 0. 0 plus 0 will give you 0. So T itself, T1 and T2 are all going to be 0. I wanted to establish that before we proceed. Write it down. Write it down. Now, write it down. Write it down. So we've been able to establish two things before we even start the calculation. Okay. The first thing we are establishing here is that T1 is 0, T2 is 0, F1 is 0, F2 is also, sorry, F1 is 37, F2 is 37. So now we start straight from which F? We start from which F?
F3.
F3. So you're going to start from F3. If I were to write the formula for F3, what will it be? I hope you wrote the formula. What would be the F3 formula? F3 is going to be sorry, not even F3. We have to do adjusted F3. So that's what you're going to calculate. Adjusted F3 will require you to have F3 plus T3. Adjusted F3. That's for period 3. Okay, so let's start with the F3 now. What is this F3? What's the value of the F3? If you can remember the formula. The formula says Alpha is now what? 0.5, isn't it? Keep that in mind. Alpha is 0.5. In fact, I'm writing this formula. Somebody who's sitting there, the person who's saying that, I don't know him. I'm writing this formula. This formula is what I'm doing. This one. This one here. Alpha dt, blah, 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 blah. Okay. So we are looking for F3. So this one should be D2. And this one should be F2. So we know this value to be 0.5. What is D for F2? Let's go back. What is F2? What is F2? F2 is 37. Do you remember?
37.
37.
So we are going to have 37. Oh, for me. We're going to have 37 plus so that gives us the whole of F3. Let me put that one down first. So that's F3. And what is T3? Let's calculate T3 first before we add them for the adjusted. T3. Now, if you want T3, just go to the formula. Here, it says that first you need to have the beta, and the beta is 0.5. You should have inside here F3. Okay, so this one is going to be F3, and F3 is what? 37. And then minus F2. What was our F2? What was our F2?
37.
37, right?
Yes, sir.
Good.
Yes.
So this is also 37. Plus 1 minus beta. Of course, beta is 0.5. So 1 minus beta is also 0.5. Multiplied by T2. What is our T2?
37.
37.
Is it 37 or 0?
0.
Oh, how can it be 0?
It's 37, no?
37. 37.
Somebody is horribly confused, and I'm horribly confused that the person is horribly confused. What were we calculating?
Adjusted F3. But you equated T1 to T2 to 0.
We equated what? Did I calculate adjusted F2? I think I should have calculated adjusted F2 before we start.
Doc, please, I have a question.
Hold on. Because I'm watching so many things on the screen. Let me just kill some of them. But just keep the following in mind. You'll be helping me because when I told you guys to be keeping them in mind, you didn't write them. So that's why. We already have the following here. Okay. Please write the following down. T1 equals T2 equals 0. F1 equals F2 equals 37. Put those ones down first. Put those ones down. Because you're not writing. Have you written them?
Yes, Doc.
Okay. So now we should first calculate AF3. That's what we should calculate first. Or let me put it this way, AF2, not AF3, AF2. That's what you should calculate it. Which will be what? F2 plus T2. What will be that? What will be F2 plus T2?
37.
37 plus 37.
No, it can't be 37 plus 37.
No,
Massa.
37 plus 0.
I told you to write
37
things down.
plus
He's
0
just
is equal
mentioning
to
things in his head.
37 plus 0.
Massa, stop
37 plus 0.
Plus 0.
No, but you
37
getting it
plus that.
correct is not my issue. You getting it correct is not my issue because others are saying it, you're also saying it. But know what we did. I said write the following down. You wrote it down, but you didn't write it down. That's why you're telling me something else. People who don't pay attention, then they'll come and struggle and say that, Doc, I was sick on that day. You know, just write some simple things I've said you should write down. You are not even willing to write that one down, and you're just vomiting answers there. All right. So you're laughing. It's not a joke. You're laughing. It's not a joke at all. It's serious. If you knew what's happening, about to happen, you wouldn't be laughing at all. Yes, Elsie, your hand is up.
Look, I had a question. So you've actually cleaned it, but previously you said that the F3 was equal to 37.
But
And I
even if
wanted
I've
to,
cleaned it, I told you to write it too.
yes, I've written it, that's why I'm saying it. So previously you said that what you wrote was F3 was 37. So I wanted to find out, are we using
We
the
haven't come to
new,
that. I told you that we first have to calculate AF2.
okay,
We
okay.
haven't come to F3. We should have done F2 and then T2 and then AF2. AF2 is adjusted. We didn't calculate adjusted before we move on to the F3. So now that we've calculated adjusted, we are about to start the F3 afresh. Yes, Foster.
No, please, I wanted to find out, please, which procedure are we following when it comes to the adjusted F3? F3
When
we
it
are
comes to the adjusted, remember that adjusted FT plus 1 is equal to the FT plus 1 plus the TT plus 1. This is it. This is it. Anytime you are calculating the adjusted, okay, you should have, this is the formula you're looking for. But to do that, you must have two items. One is alpha and the other is beta. In this case, it looks like the beta was 0.3, right? The beta was giving us 0.3. And the alpha is giving us 0.5. So that's it. The beta is 0.3. This is 0.5. And this is 0.3. So the first thing you need to do is to calculate that and then add this, and that will give it adjusted. And this one, first one, is the one we did with the simple exponential smoothing. In our example here, I told you, and again, most of you are not writing things. This is a shocker. Okay, I told you that T1 is the same as T2, and that is the same as 0. And I also told you that the F1 is the same as the F2, and it's equal to 37. This is what I told you to put down. So now we are ready to calculate AF1. Sorry, AF2. Because AF1, there's nothing there. So how do you calculate AF2? To calculate AF2, you need F2 plus T2. What is our F2? It's here. It's 37. What is our T2? It's here. It's 0. Therefore, AF2 is 37 plus 0. So the adjusted exponential smoothing for period 2, February, is going to be 37. So if you create a column for that, it's going to be 37. Remember that alpha is 0.5, beta is 0.3. We didn't use them because we already have calculated this. Now we are going to find our AF3. First, are you with me?
Yes, yes.
Okay. Now, how do we find AF3? The same formula. We need to get F3 plus what?
T3.
T3. Now, for that one, they are not given here. So you got to calculate them one by one. So first thing we got to do is to calculate the F3. What is the F3? Go and check your formula. Okay, and you will know the formula, how to go around it. The F3 is the alpha first. Okay, so the alpha is what? 0.5, isn't it? And then go and check the formula you have in your note. The alpha multiplying the demand. The demand is the previous. So if it is F3, we are talking about the demand for period 2. And that demand for period 2, when you look on the table, what is it? 40. Okay. So now you write into bracket 40. Then plus 1 minus the alpha, which is 0.5, multiplying the forecast for the period 2. The forecast for the period. Again, look at the formula. Your eye should be on the formula. If I'm talking and your eye is on your formula, the FT plus 1 formula, you can't follow me. So it is 0.5 into bracket what? We already found our forecast. F2, what is that? 37.
7.
So you now put 37 here. And this is going to give you the F3. When you work it out, what will you get for the F3? You should get
38.5.
Good. You should get 38.5. That is your F3. But we are not done yet. You need that T3 and come and substitute it here and you get your AF3. Now, what is a T3? Check it. The T3, let me just give you, is supposed to be the beta. Again, check your formula. Into bracket the F3 minus the F2. Okay. Close the bracket plus 1 minus the beta. 1 minus the beta. And then T2. So watch it. When you look at the T3, it has a beta multiplying the forecast and its previous. In this case, the forecast is 3, its previous is 2. And it has 1 minus the beta multiplying the time trend, which is the previous. That's it. So your eye must be looking at the formula. Your eye must be looking at the formula. Okay, so now let's find the answer here. What is beta? Beta is 1.3. What is F3? F3 is what we just found.
38.5.
38.5 minus F2.
38.5.
What was F2? Obinum the area answer more count.
37. 37.
So 38.5 minus 37, what do you get?
1.5.
So you get 1.5 plus 1 minus the beta, which is what?
0.7.
0.7. Multiplying the T2. The T2 was 0.
0.
Therefore, if this one will go, our time trend is going to be just the 0.3 times 1.5, which will give you 0.45. Very cool. So now we have our values. We have the value for the F3, we have it. And then the value for the T3 too, we have it. The value for the F3 is this. And the value for the T3 is 0.45. We add them together. And that will give you the adjusted F3. What is adjusted F3 now?
38.95.
Very good. That is it. So if you work this thing out, you get something like this. So this was our adjusted F2. Okay, for adjusted F3, you need to get a T3 and then the forecast for 3. Okay, And then when you do that and you add these two together, you're going to get, just as with the 38.5 plus, you get 38.95. Now, if I tell you to calculate adjusted forecast for period 4, can you do it? Of course.
Okay.
What do you need to have first? You need to have the formula first. It's going to be AF4, isn't it?
Yes.
Equals to what? F4 plus
4 plus T4.
T4. Okay. Now, first we need to find F4. Okay. We have already found it. Go and check it. F4 will give you 39.37. It's just taking that same alpha of 0.5 multiplied by the demand. In this case, the demand for last year. Okay. The demand for last year. Or the previous. If this is F4, the demand will be F3. And then you take the 0.5 again, multiplying the forecast. And the forecast is what would have been calculated, previously. Not this one, but then the forecast for F3, not adjusted for it. And that'll give you this. Then you now find the time. The time is this. Okay, you substitute all of it like we did. And just as the previous one gave you 0.45, this one will give you 0.69. You now add the 0.69 to the 39.75, and then that will give you 40.44. That is going to be the adjusted forecast for period 4. And then you can do for period 5 and period 6 and 7. When you do all of that, you're going to get this. So you're going to get the forecast here, the trend here. When you add the two, that will give you the adjusted forecast there. The forecast here, the trend here. When you get the next one, you're going to get the adjusted forecast there. And you can see clearly that the trend is rising. The forecast is rising. The adjusted is rising. But you can see that adjusted is consistently bigger than the forecast. The adjusted, because you've taken care of trend. Because you've taken care of trend, time trend. If you don't take care of trend, you will have a challenge. I know this part here might be a little bit daunting, isn't it? But again, it's not a problem. Go and calculate the adjusted for year 5. You do it hard till they get to the end. Then you say that, okay, now I know. Because the thing is that as your eyes start looking around, hey, which one is this one? Hey, which one is this one? Hey, your mind now begins to be at ease with the adjusted. Some people, when they are learning like this, and they recognize that they are leaving the Zoom one by one right now, as I'm speaking. The number was 138. They are leaving the Zoom one by one. This is how I get to know people who are showing real interest, people who actually paid for the thing, and those who didn't pay. So if you work it like this, it's going to be very, very cool for you. So go and complete the rest at home. Now, I told you that there is another method, and this is known as the regression. Okay. So we have examined the moving average, the weighted moving average, the exponential smoothing forecast, the adjusted exponential smoothing forecast. Now, we are going to look at something that time series doesn't look at. When demand displays an obvious trend over time, obvious trend or least squares regression or linear trend line can rather be used for the forecast instead of the adjustment. And this is a very cool area for most of you. This is an area you can score because here you have a dependent variable and then you have independent variable. In this case, the independent variable is a time. So what you are saying is that time affects demand. Time affects demand. For example, some people, clearly, their demand was not going up, but this period, they are increasing their demand because of what? Time, season, whatever. There is a formula for this time trend. It's just like the equation of a line. If you can remember, the equation of a line is given as y is equal to mx plus c. It's the same thing like that. Y is equal to bx plus a, or y is equal to a plus bx. Okay. The a is the intercept. The b is the slope of the line. But in this case, we say that the b is the change in the x. This B is a change in the X as a result, the change in the Y as a result of the change in the X. Because if you take the partial derivative of the Y with respect to the X, what do you get?
You get B.
You get B. You get B. On true. If we attack one down, write it down so that you can remember it. So that gives you the value of B. So the B is the marginal effect of the X on the Y. That's a B. Okay, you will interpret this in exam. So that's what I just did. The marginal effect of the X on the Y. Now, I told you that before you can get this equation, you need the data on demand and you need data on time. X is the time. Y is the demand or the orders. Okay. And then you can be able to now forecast for demand for X for the next period. Let's take an example. Now, this system actually uses something known as ordinary least squares or OLS. OLS. This is the easiest one. This one is the easiest one. OLS means that you need to find the formula for the A, the formula for the B. How do you get the formula for the A? It's there. It's there. Okay. The formula for the B is giving us the sum of xy minus the n x bar y bar. What is x bar y bar? What is x bar y bar? Who can raise their hand and tell us? What is x bar y bar?
The mean.
I say raise your hand. What is the x bar y bar? You know, when you are guessing, that's when you sound the answer into the air. Okay, it looks like I have to get into my momentum now. So the x bar, y bar are the means of the x and the means of the y. Okay, x bar is the summation of the x, okay, divided by the sample size. Y bar is the summation of the y divided by the sample size. Once you get the two, you can now substitute them and find the A because the B is the coefficient. Okay, let's take a data set. So this is a data set. Once you have a data set like this, you should be able to calculate easily the x, y, and then the x squared. Now, for the exams, you might not be giving the data. You rather be giving the values, okay, the summation. So if you look at the summation of the x, if you look at the summation of the x, it's here. If you look at the summation of the y, is there. If you look at the summation of the xy, is there. So these are for period. And then the people who don't pay attention, they are the ones who keep talking now. Okay. If you get the summation of the x square, that is it. And x square is simply take the x and square it. So 1 square, 2 square, 3 square, that's why you get them here. The xy, take each number here, multiply by the number on the left, and that will give you the xy. Now we are left to finding the mean because we need the formula. Remember, when you look at the formula, it will tell you what you are looking for. You need xy. We have it, and we have the sum. We need the x square sum. We also have that. Now, we just need to find the mean here. Okay. The x bar is the mean of the x. So when you take this mean, you sum all of them up. Okay. You get 78. So you divide 78 by 12, and that'll give you the x bar. That's 6.5. You do the same thing for the y. The total of the y has been given as 557. You divide that by what? 12, and that will give you 46.42. Okay, now we can substitute them into this formula. Whatever, we know the values now. We know the sum of the xy, that is 3,867 here. We know the sum of the x squared, that is 650. We know n is 12. We know n is 12. We know x bar is above here. Y bar is also above here. All we need is the x bar, we square it. So this x bar is 6.5. We square the 6.5. And that is what you've seen I've done here. You square the 6.5. You substitute them into the formula, that will give you 1.72. 1.72. That is the coefficient. Once you have the coefficient, you can now find the A. Remember the equation? The equation was y is equal to A plus bx. Okay. But then we are evaluating them at the mean, at the average. So if I want A, I just move this one to the left-hand side. So A becomes y minus bx. But then we are finding them at the average. These things were calculated at the average. So that's why you see them, we are using the bar. So to get this, we just substitute the y bar, which is 46.42, minus the b, which we just found to be 1.72, multiplying the x bar, which is 6.5. And when you do that, you're going to get your value. A very, very nice value. And that value is going to be 35.2. That's a coefficient. That is the intercept or the constant. So A is 35. Now you can write your equation. Okay. The entire regression line is 35.2 plus 1.72. Guys, this is easy to do. Now that I know the value of the equation, okay, now that I know this, I can now substitute whatever x value. You see the x here end up at what? 12. So you are supposed to forecast period 13. What to be the y for period 13? That's what the question is asking you. And now I can find the y for period 13 because once I substitute y here, I'm going to have 35.2 plus 1.72 y. And the x value is what? 13. And that will give me the value of the y. So when you do your calculation nicely, you substitute, you do that, you're going to get the y value to be 57.56. It makes sense. So look at it. Okay, look at it here. Okay, if you look at it, the demand is rising. The demand is rising. There's a little bit of dip there, but it doesn't matter. It kept rising. And so you can see that by forecasting, you are able to now forecast that in period 13, demand will be what? 57.56. So this has been able to be used. You can use this thing that we just done to forecast. But then that is not the only thing. All of these forecasting, remember, you can identify the forecast error in all of them. Okay, we shall look at that in time, but just understand what we've done. Because what we just done is a very critical thing. If you have a data set and you have the following summation at the bottom, you should be able to calculate the linear trend line. Now, and of course, this is a linear trend line. In fact, I've done it in the Excel. Go and check. If you go to the Excel here, okay, and you click on a sheet called Linear T. Okay, in fact, I can delete it and show you how I did it. Okay, so all you got to do is just scatterplot the data first. Scatterplot them. Click the whole thing here. Click the whole thing. And then go to Insert, and then Insert Scatter. Insert Scatter, the first one. Once you click on this scatter, this element will come, the one at the top. This is actually called chart design. Click on quick layout, and choose layout number 9. Okay, this is layout number 9. And once you click on layout number 9, the whole trend line will be drawn nicely for you. In fact, you can click here and maximize or stretch. Click inside here and even bolden. Control B to bold the equation. You can even move the equation to this side. And you can actually click and change the colors. Okay, so when you click here, you can change the colors to whichever one that you want to have. You can delete the legend so that it becomes bigger. You can delete the title so that it becomes clear. And you can see that that's exactly what we had, 35.2 and then 1.72, corrected 2 decimal places. That's exactly what we had. And you can see the trend line as well. The R square is 80%, okay, which tells you that 80% of the variation in the dependent variable, in this case in Y, has been explained by the X. So you are able to generate this time trend very nicely here. Now, let's go back. Let's go back. So that time trend is what he was trying to also generate there. The actual data is around it, and the time trend is just straight on. So you can use the time trend here, the linear time trend, to also predict the next month information, just as all the others we are using. This is where it gets interesting if there's time. This is why I said if there's time. If there's time, fine. If there's no time, don't worry. After you have calculated the time trend, remember that what you've just done is for the year. You did it for the 12 months, and you even predicted the month 13. But what is a seasonal pattern? A seasonal pattern is a repetitive up and down movement in demand. So even for your 1 year, you can have a seasonal pattern in it. I'll show you a typical example, and then you can see. It can occur monthly, it can occur weekly, it can occur daily. And you can have a seasonally adjusted forecast. You know, you can develop a seasonally adjusted forecast by multiplying the normal forecast by a seasonal factor. Watch the word. Normal forecast is what we just did. You can multiply that normal forecast by a seasonal factor. What is that? What is that seasonal factor? A seasonal factor can be determined by dividing the actual demand for each season by the total annual demand. This is it. This is simply a seasonal factor. So if you know each season, let's say there are 4 seasons, okay, you can take each season demand divided by the annual demand. Okay, so if let's say total demand is 100, and for this quarter it is 60. It is 60 divided by 100, and the seasonal factor will be 0.6 for that particular season. Okay. Now, seasonal factors, as you can see, will lie between 0 and 1. Okay, because you're dividing it by the total, and they tell you the portion of demand assigned to the season. So you will know which season is doing well, which season is not doing well. Now, the seasonal factors are multiplied by the annual demand. To watch here. Here, I said that you divide the actual demand by the total to get the seasonal factors. Before, I indicated that seasonally adjusted forecasts can be developed. How? By multiplying the normal forecast by the seasonal factor. That's the same time coming here. Okay, multiplying the normal forecast, okay, by the seasonal factor. Now, the seasonal factors are now multiplied by the normal forecast. Okay, watch it, the same thing. Normal forecast, okay, or the annual demand, to get the adjusted forecast for each season, There's an example here that we can look at. I'll go slow so that you can get it, because by doing this very one plus everything we have done, that is 25 months. Wishbone Farms is a company that raises turkeys. It sells the turkeys to a meat processing company. They will process it and it becomes corned beef. But the peak season obviously occurs during the 4th quarter of the year, October to December, thereabout. Wishbone Farms has experienced a demand for turkeys for the past 3 years, as shown below. So over the whole years, demand in thousands, okay, the first quarter, and the years are 3 different years. For each year, it has 4 quarters. Quarter 1, the demand is 12.6, multiplied by the 1,000, you it gives you 126,000 sort of. And then quarter two, 8.6 for that same year. And then on and on and on and on. And then for year three, you can see that for each quarter, okay, demand is increasing in each quarter. And then in each year too, you can see that demand is fluctuating, but increases higher, in the final quarter. When you take the quarter four alone, you can see that demand is increasing in that quarter. Right? So, and when you look at the total demand is increasing across the years. And when you look at it over year, total demand is increasing. Over the quarters, you can see that total demand is fluctuating. And then it increases only in the last quarter. Because we have 3 years of demand here, we can find the seasonal factors. How? We said it. Remember, it is D divided by the sum of the D. So it is a total quarterly demand for the 3 years divided by the total demand across all the years. So as an example, we are looking at S1, seasonal factor 1, is going to be the D1 divided by the sum of the Ds. So let's take the first one. D1 is what? 42. So D1, when you look at the quarter, that demand, the total demand there in the first quarter is 42. You divide by 42 by the 148. For each one, 42 divided by 148. So the seasonal factor for the first season or first quarter, you might say, is 28%. Okay. For the second quarter, it's going to be 20%. For the third quarter, 15%. And for the last quarter, is 37%. You remember we said that they will all add up to 1. So these are the seasonal factors, which you'll be asked to calculate. Once you have a data like this, you should be able to calculate the seasonal factors. Okay. Now, we can now find the annual demand forecast. How? We said it before. You got to multiply the demand forecast for year 4 by each of the seasonal factors, the one you just calculated, in order to get a forecasted demand for each quarter. So let's take the first one. Oh, but we need demand for forecast 4, for year 4. We need a demand. And the data above generally exhibit an increasing trend, I told you before. So Y becomes a total demand for the year. So we have to compute the linear trend line for the 3 years of the data. Just for the 3 years of the data. And then use that to raw forecast the estimate. So watch it. So our Y, X and Y will be those information that we have. You remember we just got this information. Okay. You got 42 here. You got 29, 21, 55. Okay. Remember, these are quarters. Okay. And then what we are having down here are the demand, the total demand. Okay. So here, that is wait. Where is the... Look at the years here. It's the years we are using, not the quarters. The years. Use 45 here. Let me just unlock it. Come on. Hey. 45, 50, and 53. These are the yearly demand. Okay. Not the quarterly demand. The yearly total demand. Before you sum them up divided by the overall 3 years. And these are they will now make up what? They will now make up the demand values. And then the time, they will now make up the, what do you call it? The Y. And the time becomes that of the X. So that's what we are going to do. Okay. That the Y, which is the demand, Y, which is the demand, is a function of the X, which is a time. Okay, so the demand is a function of time. And so the demand is 45, 50, and 53. The time is going to be 1, 2, and 3. So that's what we are going to use to do our regression, which is very, very cool. So watch it. So for each one, just as we did for the normal regression, our information here is just 3 years or 3 periods. We can find the XY for each one of them, X squared for each one of them. We now get the totals. We can find the means for each one of them. Okay, X bar and Y bar. We can get to them. And then what do we normally do? We can now write the regression equation, isn't it? The regression equation is Y is equal to A plus BX. Okay. And then you find the B. How do you find the B? You use the summation XY, okay, all of the divided by that. So you substitute that, okay, and then you find the value of the B, and that will give you what? 4.3. Now, once you have the 4.3, you can easily use it to get the A, isn't it? Because remember, from the equation, you can make A the subject by moving the BX to the left-hand side. And when you do that and substitute the 4.3, you're going to get A to be 40.97. So your actual equation, the linear trend equation, is this. So you can use this one to predict the forecast or forecast for year 4, which is what the question will always ask you. Okay, use it to forecast for the next year. Well, it's just a matter of putting the year 4 here. Okay, wherever you see the X, you put 4 there. That's it. And when you put the 4, you're going to get 58.17. So you can see again that whilst this was trending upward, 45, 50, 53, you can see that the next one is still trending upward, which is 58.17. So we've been able to predict the year 4 demand, just as we knew year 1, 2, and 3 demand. Now that we've gotten the year 4 demand, we can now use it to do for each quarter. Because now that we know the year 4, we can easily find the quarter, isn't it? It's a beautiful work. Because remember, for each quarter, let me just take you back. For each quarter, we didn't have the quarterly demand. Okay. We didn't have the quarterly demand for each individual quarters. So we can now use the annual forecast here. Okay, we can find the seasonally adjusted forecast. And how do you find the seasonally adjusted forecast? Well, we already calculated this, if you can remember. We said that seasonal factor is the demand over the sum of that. Okay. Now, the seasonally adjusted forecast is always given by that seasonal factor we have here, okay, multiplied by the one we just calculated. Okay, the forecast we just calculated. And the forecast we just calculated is the 58.7. All of them are going to have that for each season. So you do that for each one of them. Each one of these seasonal factors multiplied by that for each of the seasons. So substitute that, and you get, for the first one, you get 16. The second one, okay, all of them are going to use that 58. Okay, we knew the seasonal factors percentages, all of them. So for the next seasonally adjusted forecast, we are able to get it for each one of them, all the 4 of them. You get the value 16, 11, 8, 21. In other words, let me just show you from here. In other words, what you are doing is that you are creating a forecast. So instead, you see, quarter 1 has got 3 elements. So you are making the 4th element for quarter 1, the 4th element for quarter 2. Okay, because now we've gotten their year 4. Their year 4 value, we've gotten it already. And so now that we've gotten that year 4 value here, we got it here. It's down there, it's in the middle here. We got it. That was 58 point something. Now that we've gotten that, what are the corresponding quarterly years? That is what we are finding. Corresponding quarterly demand. And that is what we just calculated there. And once you get this quarterly demand, you compare with the actual demand they had. Go and check it with the actual demand they have. Okay, and you see that these are relatively good forecasts. when you compare it to the other one, reflecting both the seasonal variation, the same variability that you saw in the season. That is the same thing that you are finding here. Next time, what we are going to do is I'll make some time for the forecast accuracy. That is what one of you was just about. How do you determine which of these forecasts we have done is correct? Okay, forecast accuracy. Let me see what I can quickly wrap up. Okay, I think I can. Okay, because they are very, very simple. I'm not calculating. So the difference between the forecast and the actual, that's all. The difference between the forecast and the actual, that's the forecast accuracy. And there are 4 of them here. 4 of them. These are the 4 main ones you'll be using. Okay. In fact, even in real life, these are the 4 main ones that we tend to use. Okay. So how do you calculate the mean absolute deviation? The mean absolute percentage deviation, the MSE and the root MSE. These are the formula for each one of them. They are simple, simple, simple. Look at this one. Take the demand, that's the actual minus the forecast. Take the absolute value and find the average. Job done. Okay, so let's take this is a demand. That is the first one. 40 minus 37 is 3. Okay, and then you take the absolute value, it's still 3. Each one, the actual demand minus the forecast, the actual demand minus the forecast, the actual demand minus the forecast. When you finish, you sum all of them, which is the 53 here, and divide it by the total number. Okay, and once you divide it by the total number, that will give you, let's see. Okay. If you divide it by the total number is, you always divide it by n minus 1. Okay, the total number is 12, so 12 minus 1. And that will give you this. This is it. So the mean absolute deviation for the exponential smoothing one is going to be that. It's going to be 4.85. Put it down. Okay. Now let's look at the other ones. So I've done these ones in the Excel for you. This is the first one I just did. Okay, if you like, you can see 3.1, 1.83, that's it, 3.1, 1.83, and then on and on. And that will give you the absolute value that we had. Then the absolute value divided by the 11, that is a 12 minus 1. That is this one for the mean absolute deviation. The mean absolute percentage one is going to be this. It's going to be this second one. Okay. That one too, the formula is there. This is when you are using the alpha equals to 3. This is when it's alpha equals to 9. And the mean absolute percentage deviation is also provided for us here. So all of these formulae can easily be computed here. Okay. Now, for the exponential smoothing, so for each of the method, you are going to calculate this. So for each of the method, you are just taking the demand minus the forecast, the demand minus the forecast, or the forecast minus the demand, or the forecast minus the demand. You take the absolute value. You sum them divided by the sample size minus 1. In our case, our sample size is 12, and it's less than 30. That's why we did the minus 1. Okay. When you do for the linear trend, you're going to get this. When you do for the adjusted exponential, for the MAD, all of them for the MAD, you're going to get this. And you can see that among all the 3 of them, okay, the MAD is the lowest for the linear trend, which means that the one you should use for your forecast is the linear trend that we just did. So the linear trend is the winner using the mean absolute deviation. What about if you are using the mean absolute percentage deviation? Well, if you use that one, you are going to get 10.3% for the first one. That one too. Someone is disturbing us. Okay, so that one too, you go through the same processes. And when you go through this same process, of course, you will not be given a whole data set like this to work in an exam. Okay, but you should know the principle. That one too, using the exponential smoothing method, you get 8.5. Using the adjusted exponential, you get 8.1. Using the linear trend, you get 4.9. So once again, which one is winning in terms of error? Which one has the lowest error? Even using
Yeah.
the linear trend.
Yeah.
The linear trend is still winning. What about if you use the MSE? The mean squared error is a very popular one. If you use the mean squared, again, look at it. It is just the same actual minus the forecast, but this time you square it instead of taking the absolute value. Okay, and then divide it by the n again. That one too is all been done here. And when you check it, the mean squared error for the first method, okay, is going to be 34.18. I think I didn't even go through that. I didn't go through that. But the first point is going to be, I'm sure that one too, the linear trend is going to be the winner. But the most important one you'll be calculating is these three, okay? The mean squared error. Let me just show you. Oh, come on. Okay, the mean squared error. As for the root mean squared error, is easy. Whatever you get here, you take the square root of it, and that's it. So it's a mean squared error, the mean absolute deviation. These two are the key ones that you'll be asked to calculate one, and then use it to determine which method is correct. But of course, you are not going to be using so many multiple methods. Maybe only one of these, you'll be asked to calculate its errors and use the errors to make a decision. Ladies and gentlemen, that brings us to the end of the entire caboodle. Any question? Any question, please? Like I told you the last time, when we return, we are going to go through the entire syllabus once again.